Previously, we learned how to find GCD of two numbers using the division method. But there is also one more method for finding out the GCD of two numbers. What is that method? The method is Euclid's algorithm. Now we'll see how to find out the GCD of two numbers using Euclid's algorithm. So Euclid's algorithm is simple. So if you have GCD of a comma b, so the GCD of a comma b is a if b is 0. That means if one number is 0, you can return the other number as the GCD. Or if it is not 0, you will continue in the same GCD of b and GCD of a comma b, a mod b. Let us take one small example. Let us try to find out the GCD of 15 and 45. So in place of a we have 15, in place of b we have 45. So according to this formula, so GCD of a comma b is equal to GCD of b. So b, in place of b we have 45, GCD of b comma a mod b. So in place of a we have 15 mod 45. So 15 mod 45 is 15. So we get GCD of 45 comma 50. So we are not done yet. We have to still continue. GCD of 45 comma 15. In place of a we have 45. In place of b we have 15. So GCD of a comma b is equal to GCD of b, that is 15 comma a mod b. 45 mod 15. What is 45 mod 15? 0. So GCD of 15 comma 0 is, as you can see, it is 15. So GCD of 15 and 45 is 15. Now I'll give you a small homework. Can you try to find out GCD of 120 and 295? Try it yourself first. See here, in place of a we have 120, b we have 295. Let us substitute. GCD of a comma b is equal to GCD of b comma a mod b. So 120 mod 295 is 120 itself. So we'll get this. The next step, so we have a as 295, b as 120. So a comma b, GCD of a comma b is equal to GCD of b comma a mod b. So if you divide this, we'll get 55 is the remainder. So in the same way, we can continue like this. So in the end, so GCD of 120 and 295 is 5. Can you try to find out the answer of GCD of 1970 and 1066? Please try it yourself. Now, we'll go to the next one. So this is pronounced as Eulers Totient. What is this Eulers Totient function? It is represented using phi. So it is written like this, phi of n. So what this number does is, it counts the number of integers between 1 to n. If you are saying phi of n, that means you are counting numbers from 1 to n. What kind of numbers? That are co-prime to n. So how many numbers are there that are co-prime to n between 1 and n? How many numbers are there? Isn't it? So we need to remember one small thing. Two numbers are co-prime if their GCD is 1. Let us take one small example. So phi of 6. Phi of 6 means how many numbers are there from 1, 2, 3, 4, 5, 6 that are co-prime to 6. How many numbers are there from 1 to 6 that are co-prime to 6? That number we have to find out. So here, these many numbers are there from 1 to 6. Out of these 6 numbers, we should find all the numbers that have GCD as 1 with 6. So out of these 6 numbers, how many numbers have GCD as 1 with 6? So here, only 1 and 5 have GCD of 1 with 6. Remaining things they don't. So how many numbers are there with GCD 1? So 1 and 5. That is, this is the first number, this is the second. Two numbers are there. So GCD of 6 is, what is phi of 6? It is 2. That means two numbers are there from 1 to 6 that have GCD as 1. Next, let us solve this. Phi of 9. So this is also same way. So how many numbers are there from 1 to 9? So we'll write down. Then we have to find all the numbers that have GCD as 1. As you can see, how many numbers are there? 1, 2, 4, 5, 7, 8. So how many numbers are there? 6 numbers are there. So GCD of, phi of 9 is equal to 6. We'll go to one more theorem. This is very important for solving the problems in future. If P is a prime number, then GCD of P comma Q is equal to 1 for all Q greater than 1 and Q less than P. We'll understand by this with a small problem. That is, if P is a prime number, then instead of taking the slower method, we can simply write phi of P is equal to P minus 1. That is, P should be a prime number. For example, since 5 is a prime, so we can simply write phi of phi is equal to phi minus phi of phi is equal to phi minus 1. That is 4. Now, again, if you apply the same thing, see 13 is a prime number. So if you apply this formula, phi of 13 is equal to 13 minus 12, is we get 12. Then we have one more theorem. If P is a prime number, in order to find out phi of P to the power of k, we can write it like this: phi of P to the power of k minus phi of P to the power of k minus 1. Again, we'll also solve this with a small example. In order to find out phi of 2 cube, so we can substitute here 2 cube minus 2 to the power of 3 minus 1. So we'll substitute in this formula. 2 to the power of 3 is 8 and 2 to the power of 3 minus 1 is 2 square. So 8 minus 4 is 4. So phi of 2 cube is 4. Then if there are two prime numbers that are relatively prime, so we can write it like this: phi of a b is equal to phi of a into phi of b. For example, see here 3 and 5, they are already relatively prime. See here 15 can be written as 3 into 5. So 3 and 5 are relatively prime. So what is phi of 3? It is 2. What is phi of 5? It is 4. So 4 into 2 is 8. Then can you tell me what is phi of 49? See, you cannot write it like this. See here, phi of 7 into 7. So you cannot write it like this. See here, so both the numbers should be distinct. See here, as you can see, 3 is different, 5 is different, isn't it? So you cannot have the same numbers. So instead of that, you should write it in a different way. As I already told you, you cannot write it like this. You cannot say phi of 7 into phi of 7. Phi of 7 is equal to 6 into 6. That is 36. See, this answer is wrong. You cannot write it like this. See, we are speaking about phi of 49, because this method is wrong, because these two numbers should be different. Instead of that, what you can do is you can write it like this: phi of 7 square. Phi of 7 square. So what you can do is phi of 7 square minus 7 to the power of 2 minus 1, isn't it? So 49, 7 square 49. So 7 to the power of 2 minus 1 is 7. So 49 minus 6. So that should be the answer. Can you try to find out what is, in the same way, what is phi of 20? You can apply the previous formulas and try to find out. So phi of 20 is equal to 8. In the same way, phi of 21 you can try. The answer should be 12. Phi of 19 you can try, 18. Phi of 45 in the same way you can try.